if n is even integer, then n squared plus 1 is odd integer. I really they just said odd, I think. They just said odd. Yeah, it said n squared is odd. So that's what we're gonna be having from there. N squared plus 1 is odd. So now from here, first, guys, some of you didn't even write this. I don't know, you didn't even write proof. The question is, what are you trying to do? Automatically, when there's no proof, you get a 0. You say, right? Don't get a 0. Make sure you don't get a 0. Secondly, after writing proof, you need to assign your statements. P, Q. You didn't assign, most of you. Some they did assign, some they didn't. Then we're saying that if n is even integer, that is our P. N is even integer. Then they say n squared plus 1 is odd. N squared plus 1 is, then we're going to add integer. Most of you are not even writing an integer here when you're saying those things. Then after this, I have to assume, you always assume P. I have to assume n is even integer. And then you don't write for such that, right? Most of you wrote such that. You must put this. Then you show us what do you mean when you say that n is even integer. 2k. You don't write this, then you say k element of an integer. You are wrong. After that, you must say for some. You say right now, for some k element of an integer. Then I'm gonna go around and highlight things which are very important here. You should do this. Proof. After that, you should assign that. And then this is very important, right? And then this is very important for some. They're going to check those things. And then you get a 0 if they're not there. I said after assuming, we need to say then. Then, after writing then, now I take a Q. N squared plus 1 is equals to, now I substitute my n. But I'm glad some they got it correctly, right? So it shows that they listened. Even those who did it, I'm sure you did listen, but then try to make sure that you follow as I say, right? Sometimes don't make sure when you're writing something, when you're writing a problem, when you're practicing, don't just write the problem, then you stop there. Try to look at the example while you're busy writing it. Is it the same as the example? Did I include everything in the example? You say right now, then this will be 4k squared plus 1. Then I factor out the 2. Then while I'm busy doing this, I'll be outlining your problems here. Plus 1. Then I'll replace this by something. Let's choose a P. Or we can even choose the M. We can even choose the M because we don't have M anywhere in the beginning, right? Then I say where or for. I said you can choose anywhere or for. M is equal to 2k squared plus 1. You don't forget this. You see, right? They're going to check if it's there. After this, you don't stop there, you must conclude. Hence, when you conclude, you are now writing this. You say right now, hence, n squared, because I said the majority didn't conclude. N squared plus 1 is odd integer. Or you are interpreting what you got. We got that this is an odd integer, and then we are correct. You say right now. So this is true for this question. Now let's do this. You are going to write the third one. Let's see. Well, let me write the third one for you. Then you will write the fifth one. So the third one, they say, or you write the fourth one. The third one, they say if n is odd integer. Let's write and see that. if n is odd integer, if n is odd integer, let me see if I'll write it for you or you'll write it. I think we've done an example based on this and also give us m, right? But I'll write it. Let me just write it. And m is odd, integer. Then let's see what they're saying here. Then what? Then nm is odd. Then nm is odd. Now let's prove this. If you check, we realize that we're gonna first write proof. Please, if you skip these things on the next try, it means that you don't want to listen, right? Don't skip them. We write proof, then we equate our statements. PQ. This is P, N is odd integer. Q says M is odd integer. And then we have the last thing, which is we'll add the R now. NM is odd. Even though they didn't say integer, I'm going to add the integer here. You see, right? Now, we are going to say now, since I have this, I'm going to assume. I assume the hypothesis. So in this case, our hypothesis there too. You see, right? It's this. Anything that comes before that, I'm just going to copy and paste this. You see, right? So here I can just easily do this. Just copy and paste. I assume assume n is odd integer and m is odd integer. And then I now write what does it mean. When n is odd, we are saying that n is equal to 2k plus 1. And when m is odd, we are saying that m is equal to, remember it cannot be k anymore because we've already chosen k. So this will be 2p plus 1. For some, I must now explain what do I mean by k and p. For some, k, p, element of an integer. I write then. After writing then, now I take this, try to prove the hypothesis. You see, right? Now I take nm will be equal to, I plug my n is 2k plus 1. Then I plug my m is 2p plus 1. And this will be 4kp plus 2k plus 2p plus 1. Then I factor out the 2. 2kp plus k plus p. Then I add my 1 there. Then I replace that by something. I can replace it by r plus 1. Where I write 4, where r is equal to 2kp plus k plus p, which is an element of an integer. Right? Then I conclude. I say hence, when you conclude, remember I said that you're going to write the assumption. So I might as well copy this and paste it there. Yeah, you're going to write the conclusion, not the assumption. You write the conclusion. So I might as well copy and paste. Hence, mn is odd integer. Any question based on this before you can write a D? Any question? So I'll send this right there when we are done. Any question? So if no question, let me do this. You are going to write now. And this, let me open it. You are going to write this. Write this. I'm going to send it now. Make sure it's right.